Okay, so we are here today at the Physics and Engineering Festival. It's part of Texas A&M University. We do this every year, and things are just going off, and there's science everywhere. It's really amazing. It's a one-of-a-kind event right here in College Station. I can't think of a better place to be right now. And so I'm excited to just walk around and interview as many people as I can, get their opinions, that just come here to celebrate science, physics, and astronomy. I mean, there's nothing better than seeing what other people think of all the hard work you put into what you do every day. So that's what I'm going to do.
Barrel, 55-gallon drum, steel drum. We put water in. Now we're heating up water. The steam is coming a little bit. We are waiting to have more steam because water boils, steam rises, it replaces some air. And then when we see steam coming, we will close it, we will seal it, and then we will put it in cold water. We will pour cold water, we will cool it down. And then we will get difference in pressure because inside water vapor will precipitate. Pressure will drop. Atmospheric pressure from outside, difference in pressure will collapse the drum. We'll see what happens. We'll ask for forgiveness if it doesn't work.
Oh goodness. Oh! Woohoo! That was a good one. Wow. All right. What do you think of the festival so far?
It went good.
What are some of your favorite demos you've seen today? The science you've seen?
The depth charge.
Oh yes, the depth charge is a good one. Yes, I like that one too.
I really want to do that thing.
You want to do this one?
I just want to do it.
Oh yes, it's worth waiting for. I agree, it's a good one. So have you been here before?
Yeah, no.
No, okay. So do you want to come back next year?
I just want to stay here.
You want to stay here a whole year?
Yep.
Okay. Well, that might not work out, but I like your initiative. Okay, we're gonna keep moving around, but it was great talking to you. So this one's called the Fresnel lens, and you literally can just burn things with the sun using a lens. It's pretty incredible, actually. It would be great for maybe some campfires. I don't know, but how you would haul this?
It's actually quite light, surprisingly. It's made from plastic. This is actually used to be an old TV that we harvested from, so not too heavy. We're capturing the energy of the sun, right? So we've got a large area here. What we call intensity is energy per area, right? And so we're going to take all of this area, all this energy that we've collected, and we're going to focus it down to a single point. The prisms refract it and focus it down to a single point. And so the same amount of energy that's spread over this big area gets put down onto a single point. And that's intense enough to melt rock, melt through metal, boil water, and of course, burn some wood. We can see we've got a wider area here. And as I tighten it in, I try to focus all that energy down to the smallest point possible, and we create fire.
Very cool. I love it. How are y'all doing today?
Doing great, sir. How about yourself?
I'm really happy to be here, and I just want to know what this demo is about.
So basically, this demo is about methane gas and the Leidenfrost effect. Methane gas is a flammable gas that comes from that tank right there. And then we put it into the bucket, which has a bunch of soapy water, so all the bubbles fill up with methane. So essentially we got a bunch of flammable bubbles. And now if we light it on fire...
That happens because when we light the bubbles evaporate, and so the gas, the vapor from the bubbles rise. And as the fire rises with the gas, that brings the fire all the way up until it reaches its maximum height.
So now what I'm gonna do is I'm gonna burn my hand with the bubbles. So I'm gonna put all the bubbles.
I don't believe you.
You don't believe me?
I don't believe
All
you.
right. Well,
Alrighty, you're good to go whenever you're ready.
here we go. And I am perfectly fine. Now, the reason is because of the Leidenfrost effect. Basically, I stuck my hand in the water, and the layer of water protects me from the fire for just a fraction of a second. It's pretty cool.
And you probably don't recommend kids do this.
No.
No.
Kids should not do this. Your parents would not appreciate it.
Do not try this at home.
No.
Yeah, do not try this at home. Put that on there. So where are y'all from?
We're from Killeen, Texas.
Killeen, Texas. Have you been here before for the festival?
No, this is our first year.
Oh, great. Do you think maybe you'll come back next year?
I think we'll come back next year.
Okay, great. And so far, what's your favorite thing you've seen?
So, baseball.
Throwing the baseball.
The baseball. Yeah, that's a good one. And so,
We started late, so we just started right now.
okay, so there's a lot more to see. I hope y'all are having a great day and just keep at it.
Yes, sir. Thank you.
Thank you. So he claims he can get 75 miles an hour. So this thing can tell us how fast he throws. We'll see. So how confident are you can get 75?
I'll give myself like a 50% chance. Because I don't play baseball, but we'll find out.
Oh, we got 46. I'm sorry, sir, but that's not very close to 75. Oh no.
I think I just need like 2 days of practice and I should be good.
Yeah, I have faith in you. Does that make a difference?
I think like I just need to talk to someone who's good at baseball, and
That's definitely not me.
No, I think if you tell me that you are.
Oh, okay. Yeah, I could throw a wicked ball, man, and I have faith in you.
Okay, so next time I try, I'll hit 140.
You're going higher? You're supposed to go lower. Set realistic expectations.
All right, 200.
Okay. All right. I think this interview's over.
We've got a trebuchet here, and on one end is a very heavy weight, and on the other end, we're gonna attach this little pocket here by a string, to the other end of this rod. So it's gonna act as a lever. We have this pulling down right here, and it's gonna send this end flying, and the ball's gonna get launched because the string's gonna come off. And
Yeah. How far do you think it'll go?
right before the sidewalk over there. It'll almost.
Okay.
You wanna fire it?
Sure. Launching for science in 3, 2, 1. Oh! I almost. Do you love science, or what is your favorite school subject?
Science.
You are into science. Before you came here?
Yes.
That is awesome. So you actually looked forward to coming here today, right?
Yes.
That is great. We don't have enough kids that love science. Well, we also have lots of demos. So what is any other demos you're looking forward to?
Well, I like the one with the. So there's sand and it can't get wet.
Oh, I think that's liquid sand.
Yeah. Yes.
Yeah, that's a fun one. Do they let you actually touch the sand yourself?
Yes.
Yeah, that's a good one. Anything else? Any other demos?
Well, the black barrel over there, and it went in.
Yes, that is a brand new demo this year. We've never done it at the festival before, and I'm so glad you loved it. So you're here for the really exciting loud demos, right?
Yes.
Yes, that's what I'm into as well. Well, thank you so much for your time. You did awesome. I'm just interested, what do y'all think of the festival so far? This is your first time, right?
This is our first time, and it's awesome.
Yeah, I like it.
What are you really looking forward to today?
I honestly don't know. Explosions, I don't know.
Yeah, explosions are always the highlight. Have you been inside any of the buildings yet?
We have been inside one of the buildings. Yeah, it's pretty cool. You know, they have a lot of different desks with showing all sorts of stuff. Everybody explains everything. It's good.
Yeah, so do you think you'll come back?
Yeah.
Well, thank you for talking with us, and y'all keep having fun.
We have the racquetball smash here, and the material changes its properties when we are able to cool it to a low enough temperature. It becomes very brittle instead of that rubbery elastic, and thus it smashes under the force when it hits the ground.
Yeah.
We're also smashing flowers, which are also usually soft and are also becoming quite brittle when put into the liquid nitrogen, which is -300 Fahrenheit.
What are you doing here at the festival?
So I was doing the potato punching demonstration, but now I'm just sort of showing people around, showing people the cool physics. Yeah.
Anything else you hope to do today?
Really just taking all the demos. I didn't have time last year, so I'm really looking forward to actually getting to see them and appreciate the festival, because so much work goes into it, so we don't have much time to appreciate it ourselves.
Yeah, so can you elaborate on how much work goes into the demos?
Yeah, I mean, really, it's like an all-year preparation, especially with Deep. They're an Oregon campus that actually builds the demos for us, so they work on it year-round. And then weeks leading up to this, we're working on funding and planning and organizing, figuring out how we're going to man every station. So it's a lot, but it's worth it. It's so worth it.
I agree. It's a lot of work, but when the day actually is here, you realize all that work was worth it, right?
Oh yeah. It's so much fun to see not only the smiles on the kids' faces, but everyone. I mean, everyone loves physics.
Well, thank you for your time.
Yes, thank you.
Great. So are you having lots of fun today?
Yeah.
So have you learned anything about science today?
Yes.
Yeah? Can you tell me anything you learned?
I mixed the potion to make a ball.
Oh my goodness, that sounds really cool actually. What else have you done today?
I got to make this tower, but it's curved.
Yeah, what is that? Do you know what that's called?
It's a tower.
I think it's called Lear Tower.
Curved tower.
Yeah. Thank you so much for your time. What do you think of today?
I think it's great. I think everybody's having fun. And the visitors are having fun, and the people presenting are having fun.
So how many people do you think are here today?
They've given away stickers. Sherry told me 4,000 stickers, but that's undercount. Probably 5,000 or 6,000 people at least.
Yeah.
It's crowded.
Yeah, it is very crowded. It's more crowded than I think last year.
I think so too.
So are there any demos in particular you love more than anything?
I like all of them. And there's so much variety. And the one that I work with is the Van de Graaff. And there's a little bit of physics, but it's mostly entertainment. Make people's hair stand up.
Yeah.
But some of them are sort of like deep science, but some of them are not. So it's for everybody.
Well, all right, thank you for your time.
So this is a pendulum that demonstrates a rotation of the Earth, which since we are on the Earth, usually we don't feel that. So there are two ways actually to think about this. One way is that we stand here and look at the bulb as it swings back and forth. But if we come back a few hours later, it will be swinging back and forth in a different direction. As somebody on the Earth, we see that the direction has changed. That's our perception, our view of this phenomena. The other view is that we think, okay, we are detached from the Earth. But in our view there, we will see the bulb will be going back and forth for a long, long time.
Okay.
If we wait for 24 hours, what difference do we see? The Earth moved to another spot, and the bulb is still doing that. It describes very well what we can observe here, but in a very different way.
Well, hey, thank you for your time.
Hi, this is the Van de Graaff generator. We basically have these belts here. One of them is rubber, one of them is silicone. And basically they're rubbing against each other to build up that charge. And that charge basically travels up to the sphere. And we have this static electricity built, which basically goes into the person that's touching it. And they have that static electricity in them, basically. And it's able to move up their hairs. It needs to be a very light hair because this is only such a certain amount of force.
I don't think I have enough hair for this.
Yeah, you need some really light hairs. You need to be really good at being able to have that light hair to move up.
Oh, yeah, I do see it. Yeah.
Mine goes.
That's awesome. Oh, my goodness.
Okay, maybe a bit strong, but mine is very thin and fine hair, which makes it very easy to go up quickly. And yeah, good?
Yeah, that's awesome. I love it. Thank you. Thank you for your time. So what are you doing here?
We're doing the smoke ring machine.
Smoke ring machine. So how does this thing work?
So whenever you push the diaphragm, it increases the pressure in here and forces the air out. It wraps around itself, creates a vortex, and then that travels up and you can watch it go to the second floor.
Oh, wow. Okay. Oh, wow. There it goes. So it's like somebody could be up there and catch the ring, huh? Oh! Can you shoot it off?
Yeah.
Okay.
You just stand here and...
Okay. I don't... Oh, he's about to shoot it off. You can... Oh! Nice! That was a good shot. Well, have y'all been to the festival before?
Yes, last year.
So your return? Okay. Are you going to come back next year maybe?
Maybe.
Maybe. Make an annual thing, just every year? Say again?
We're moving in.
Oh, wow, okay. Well, there may be room up on the 6th floor for you.
You want to live here?
No, I don't know. I don't think that would work out. But hey, I'm glad y'all are having fun. Just keep having fun. That's all we want.
Say thank you.
Thank you.
Yeah, so I'm Dr. Kevin Kelly. I'm an assistant professor in the Department of Physics and Astronomy, studying physics all around us. And so what we're showing here today is called a Rubens tube, and it's a great way of visualizing how sound waves work, but with fire. So we've got a piano hooked up to a speaker, and that speaker is sending sound waves down and back through this tube that's filled with propane gas. The flame that's on top is lighting that propane gas on fire, and these sound waves are causing pressure to change all throughout this tube. Sound is a pressure wave traveling from a speaker like me to our ears hearing this noise. And depending on the size of that wave, whether it's a short wave that's like a high note or a long wave like a low note, you can see the patterns form from that pressure pushing the flame in and out. The piano's great, it sounds awesome, but we can really visualize sound waves by putting in specific frequencies. So we're starting at the low frequency end. Low frequency, long wavelengths. You see this big, long pattern starting to emerge. But as he dials up the frequency, what we're going to see is that these waves start getting pushed closer and closer together. And at very special wavelengths, special sized waves, we'll see these cool standing wave patterns begin to emerge. And we can even count how many waves show up on this tube. So we see he's getting into higher frequencies, higher notes. And this wave is getting smaller and smaller over time. Smaller in terms of its size. So we're at a resonance here. We can count how many waves are showing up there. 1, 2, 3, 4. Exactly.
Wow. Yeah, this is probably one of my favorite demos. I've never actually gotten to play on it, but I promise you I will one day.
My name is Zach Kaufman. I am a student of the wonderful Dr. Peter McIntyre. He's emeritus professor here at Texas A&M. We mainly do research in superconducting magnets and accelerator technology. So we work a lot with high voltage and high current technologies. The voltage creates an energized electron around nitrogen and oxygen. That electron, since it becomes so energized, emits radiation because it wants to get back down to the ground state, back to its lowest energy state. And it releases that in the form of photons. So the larger the amount of energy it has to release, which in this case with the photons, or with the large amount of potential, that's a lot of energy it's going to release. So that's why it's releasing mainly the shorter wavelengths of light.
I think everybody's ready to see this thing.
Yes, sir. That's is everyone good? Yes. All right, we're gonna ride the lightning, so to speak. Not really ride it, but you know. All right, fire in the hole.
Okay, my name's Ileana Garza. I'm just kind of here presenting the tiny Tesla coil.
Okay, and this looks pretty interesting. Can you tell me what it does?
Yeah, so this power supply releases a positive voltage and a negative voltage. And so these run through this voltage module, which run into these red capacitors. And these red capacitors are connected to these two screws that have a little gap between them. They're under the Tesla coil. It's right here. I don't know if it's visible. So what these screws do, they kind of hold the charge. So the positive charge, like as it increases, it's kind of like it becomes too much. It kind of spills over to the other screw. So that's what causes a spark. So it just like constantly sparking and sparking because it charges and it releases and charges, releases. So then the rest of the charge is going up these coils and it's dissipating into the air. It's ionizing the air. And we use these copper wires to kind of like guide it and use what around it. So here we have the sparks that's going on. If we use these tiny little lights, just without touching anything together, we could see the little arcs that form with the electricity. And then you could also use this fluorescent light. It's the same concept. The closer you get, it's going to get brighter. And if I close my hands, it'll stay between there because it's kind of like if I'm closing the current. And even if I expand that, it does the same thing.
Very cool.
Yep.
So can you tell me what this is a part of? It's part of the Deep Group projects, right? So tell me how you got into that, why you do it, things like that.
Yeah, so I found out about the DEEP projects through one of my physics classes because I'm a physics major, and they kind of just like explained to us that it's an organization that kind of builds demos for the festival or for different, I guess, events to kind of spread to people how different things work. And I picked up interest in this specific group that advertise more, I guess, like electro stuff, but there's groups that focus in different topics.
Oh, cool. So you can actually kind of pick a topic or subject?
Yeah, like I know there's groups that focus, a lot of different things. Like we have a lot of like energy related things. There's groups that have focus on astronomy or more like manual things or mechanical things. So you could kind of choose, like you have an interest, you could kind of like put yourself in that group.
Okay, that sounds really neat. Well, I'm going to try to check out some other demos. Thank you so much.
Right, thank you.
This here is a Rubens coil. It's a special type of inductor. It uses the electrical signal from my phone to create a magnetic field in the center of here, and that will change based on the changing electrical signal, changes the amplitude and frequency, which produces pitch.
Now, you can see here the current is 7.
You should likely get some of the audio from this here, because it's actually producing the Super Mario Bros. Theme song.
From here, though?
From here. The metal sphere is what's vibrating, producing that sound. Take it away, there's no sound produced. If we take it away, there's no sound produced, but if we add it back, the sound is produced again. This is how a speaker functions in general. It uses a magnetic field to vibrate the internal components, and it's usually designed more optimally to produce sound. But here we have in front of you the basics of how that works. It's just an inductor changing a magnetic field based on what we intend to play.
So can you tell me what you're a part of here, why you do it?
I'm a member of the nuclear engineering. The Department of Nuclear Engineering. I'm graduating this year, and I've been to this physics and engineering festival a couple times in the past, and I just thought it was really fun, so I asked to volunteer.
My name is Zoe Cottrell. I'm a chemical engineering major here, but I got involved in DEEP last year as a freshman. This is the plasma toroid. I kind of just got involved with this project because I thought it was really cool. Okay, so down here we have a copper tube. It's acting as a solenoid, and it's making an oscillating magnetic field. That oscillating magnetic field is exciting the electrons in this xenon gas. And the xenon gas, it's a noble gas, so it prefers to be stable. It doesn't like to be in an excited state. So the lines that you're seeing is it moving towards the ground state with this grounding wire. The same thing happens, your finger can act as a ground, so if you touch it, you can see the plasma moves towards your finger.
Yeah, because they're all polarized at that point.
Yeah.
Yeah, that's neat. I love it. Thank you.
My name is Robert. I'm a sophomore electrical engineering student, and I'm part of the DEEP program that we make physics demos to show off to the people. So this is a collection of digital logic gates that I've built. This is a NOT gate. If you flip the input to on, the output turns off. The input is off, the output is on, so it outputs the opposite of the input. This is an OR gate. The output turns on if either of the inputs is on. And this is an AND gate. The output only turns on when both inputs are on. And we can use these combinations of these to create any input and output combination. So in your computer, you have millions of these, all doing independent jobs. We use these symbols to represent them when we're drawing circuits. These are the truth tables. They have every input combination and its corresponding output.
So why did you choose this one to build on?
Because it's something I knew how to build, was part of it, and it's something that I think is easy enough to understand,
For you.
for people, but also has some depth to it. And it teaches people about what's going on in their daily lives as they use smartphones and computers.
My name's Naomi, and I did want to come here, and I thought it was really cool. So.
Yeah, it is. I agree. It's also cool. But do you have an interest in science before you came here?
Yes.
Yeah, so what might be like your favorite subject?
Astronomy.
Yeah, astronomy. That's a good one. So you study the stars, the planets. So what is your favorite planet?
Uranus. I really like Saturn because of the rings around.
Yes, that's a good one. So did you watch the total solar eclipse we just had?
Yes, with my school.
Yes. And so what did you think of that?
I thought it was really cool how it got darker and how the trees, their shadows were like crescent moon sort of.
Great. So do you think, let's say 10, 15 years from now, would you want to study astronomy?
Yeah.
I know that's a long way off, but it's fun to think about, right? Thank you so much for your time. What is your favorite thing that you saw today?
I don't think I have one. There's so much, and I still haven't seen a lot of it. There's lasers. There's juggling. There's probably the science circus was, if I had to pick, was my favorite.
I agree. Science Circus is awesome. And it's interesting, I still haven't been able to see it myself. But one day I will get in there. How about you? Any other science stood out to you today?
I really enjoyed learning about LIGO, about how we can use laser lights on Earth to detect black hole disturbances in space. I never knew that. That was so cool. Yeah. That was really neat.
Yeah, I agree. It's every demo I see, I'm like, yeah, I didn't know that, and then I just try to process it, but I feel like my brain is just overwhelmed, but doing my best. But anything else you want to comment on the festival?
I think that this took very long, and I just can't believe how much work they put into this, especially because there's so many. Like I've went to like a 200, like there was one exhibit that was like the 175th, and that's not even the last. Like I'm just like, how many of these are there?
Yeah. So it's over 200 demos here. Wow. Over 200.
So I would say, if you haven't had a chance, bring your kids out. It's so much fun. It's a great day trip up to College Station. Come check out the Physics Fest.
My name's Kevin Black, and I'm a physics major here. And in this demo, we just get to see something that we often hear but never see, which is the actual waveform produced by an electric guitar as it goes to the speaker. So if I pluck here, so there is these are magnetic, and the wire vibrating over the magnet induces a current, which is then sent to this amplifier, which is then sent to the speaker, and attached to the speaker, we have these cords that allow us to see the signal on the oscilloscope.
Oh, I love it.
I'm actually an engineer. I'm doing the MXET mechatronics path, of course. This right here is a pile driver.
Yeah.
Ever heard of a guillotine?
I have.
Well, basically think of that, but replace the blade with a hammer. That's basically what this is.
Okay.
The whole main idea of the demo is potential energy. So basically, the more we increase it, the more we raise this, the higher and higher the potential energy will be.
Makes sense. Or can you crush 2 cans at once?
Sure.
Okay.
3, 2, 1.
Oh!
Yeah.
We almost got that one. So who came up with this? Who built it?
Basically, it was an idea that our professor had that we ended up just developing. Like we had an original version of this one where it was a bit more unstable. So we just spent the semester trying to just like modify it and try and perfect it a little bit.
This is the 2D trajectory demo. We're demonstrating how objects are launching, and you got to find the optimal angle. It depends on your X and your Y.
But
With this, you want to try and get right between this area right here, because if you go too high, you'll either hit the ceiling or it'll be too short, and if you go too low, you're going to be too short as well. So there's a perfect middle angle.
Okay, I'll do my best. Wow, dude. Okay, that's the funnest thing I've done today.
Nice.
All right, thank you.
Pretty good.
Thank you, man. So, as it must come to an end, everybody's heading home. I've seen as many demos as I could see today, which still doesn't feel like enough. I could spend another 24 hours here. There can't be enough people up here to see these demos. I mean, there's people everywhere, but if you can make it to College Station to see some of these demos, especially next year, we should have the Physics and Engineering Festival again. We'll post that on all our social medias, and if you can make it, I implore you to check out as many demos as possible. Bring your kids, bring your grandparents, who cares how old they are. They will love science because science is amazing. And be sure to check out our social media channels if you aren't already. We're on YouTube, Facebook, Instagram, X/Twitter, and Threads. We are doing amazing things on those, posting videos all the time, posting what we're doing in the department, and we're always looking at doing new things and new exciting demos, so that'll be fun to check out. Also, I would always say we are grateful to all our donors for the Physics and Engineering Festival. We might not be able to do this every year if we didn't have these very generous donations. So thank you so much for all that, and we hope to see you next year. And thank you. This is Ryan, out.